Good morning, afternoon, or evening. Today's Monday, March 30th, and I'm Mr. Lentz. Today we're going to be covering part 1 of lesson 19.3. And remember, at any time during these videos, you can always pause and write something down and then continue the video when you're ready, or back up if I say something or write something down that you didn't write fast enough. You're more than welcome to pause, rewind, or skip forward if it's going a little too slow for you. When you open up your student edition, this lesson is located under Unit 8, Quadratic Functions, Module 19, Graphing Quadratic Functions, Lesson 19.3, Interpreting Vertex Form and Standard Form. For this lesson, we've got to make sure we understand what standard form of the quadratic equation is. Y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. Standard form states that a cannot equal 0, b can equal 0, and c can equal 0, but a cannot equal 0. Let's look at now a couple of examples. The first one here, y equals negative 2x plus 20. If we compare this to our standard form, we see that we have a b value, which is negative 2, a c value, which is positive 20, but we do not have an a value. There is no x squared in this equation. Therefore, this is not a quadratic equation. Number 2, y equals negative 3x squared minus 4. If we compare it to the standard form, we have our a is equal to a negative 3. Our b, there is no b value. If we had a b, it would be 0, because 0 times x would be 0. So our b value is 0. And our c value is a negative 4. Because our a value is not 0, and we have an x squared in this, this is a quadratic function. Let's look at a couple more examples. In this first example, here we see this equation. We notice that we do have an x squared, and our a value, which is attached to the x squared, is 1. We have a b value of negative 4, and we have a c value of 0. It does not matter whether b or c are 0, just that a is not 0. And in this case, this is a quadratic function because we have an x squared and the value is 1. In this example over here, number 7, x plus 2y equals 4x plus 6, there is no x squared value. We do have x's, we even have a y, and we have a c, but we do not have an a value. Because we do not have an a value, this is not a quadratic function. When we're looking for quadratic functions, look for the x squared. And this does not have an x squared, so just an easy visual check, you can make sure whether it's a quadratic function or not. At this point of the lesson, we are now going to rewrite quadratic functions from vertex form, and you remember vertex form in this form. Y equals a times x minus h squared plus k. We're going to convert that to standard form, y equals ax squared plus bx plus c. Okay, in our first example here, we are going to convert this vertex form to standard form. Our first step is to expand this value here, x minus 6 squared. In order to do that, we take x minus 6 and multiply it times x minus 6. Please take a moment to expand this out. I'm going to do it in 2 different variations. First of all, I'm going to do the box method over here for some of you that like this method, where you have your x and your minus 6, and your x and your minus 6. X times x, x squared. X times a negative 6 is negative 6x. X times a negative 6, negative 6x. And a negative 6 times a negative 6 is going to be a positive 36. That would give us x squared, and I combine these two, which is a negative 12x plus 36. For those of you who do the distributive method, we have x squared. X times x is x squared. X times a negative 6 is a negative 6x. Negative 6 times x is a negative 6x, and negative 6 times a negative 6 is a positive 36. Combining my like terms just like I did here, I have x squared minus 12x plus 36. Once we have that, we substitute, these are the same answers, we substitute that back into our equation. Y equals 4 times, now I have this expanded out, x squared minus 12x plus 36 plus 3. So all I did was take this value and plug it in here. We still have our 4 straight down here. This now has been expanded out and my 3 comes down. So now I'm back to my original equation with only expanding this out. So step 2, replace that expanded value into the vertex form. Again, if you need to repeat this, go ahead and rewind the video and watch this section again. We're going to move to the next step. Again, that next step, we replace that in, and now we are going to distribute our a value from our vertex form. Our vertex form, our a value, which is our 4, we are now going to distribute this throughout this. 4 times x squared is 4x squared. 4 times a negative 12 is going to be negative 48x. And 4 times 36 is going to give us a positive 144. At this point, we need to remember that we still have this 3 hanging out over the edge, so we need to bring this down and still add our 3. At this point, my next step, step number 3, is going to be to combine my like terms. Combine and simplify. To do that, 4x squared has no other partner. The negative 48x has no other x. So all I really need to do is combine these two terms so that I have 4x squared minus 48x plus 147. Okay, let's try another example. Okay, here's example number 2. Remember, our first step is going to be to expand this right here. So please stop the video, expand this out, and write it below this equation. So stop the video now and expand that out. At this point, you should have multiplied it out and gotten x squared plus 4x plus 4, either way, either method that you chose to do. And some of you are doing the FOIL method, first, outside, inside, and last, or the distributive method. Then replacing that into that, and then multiplying now, we need to distribute this negative 3 into this, or through this. So take a moment right now, pause the video, again, distribute this negative 3 into this value in parentheses, and then when you're done, start the video again. Okay, distributing that 3 to those 3 values there, you should have gotten this, and the only thing we have left hanging out here is this negative 1 on the edge. So the last step is to go ahead and simplify. Again, this is the only terms that we have to combine here. So pause the video, combine those terms, and see if you end up with the same equation. At this point, you should have arrived at negative 3x squared minus 12x minus 13, which is the result of a negative 12 minus 1. At this point, we're going to look at our quadratic function and identify our values, our a value, our b value, and our c value. Our a value, which is attached to the x squared, is a negative 3. Our b value is a negative 12. Our c value is a negative 13. Realizing this, our a value is not equal to 0, therefore we have an x squared, and this is a quadratic function. And now it is your turn. Here are the 2 problems, both in vertex form. Please go back, look at your notes, or looking at the video and work this through step by step. Again, I'm going to list the steps. First step is to expand the value inside the parentheses that is squared. The second step is to replace that expansion inside and then multiply or distribute the a value that is in front of it. Step 3 is to simplify, which is basically adding on this last value, which is k, in our vertex form. So go ahead and stop the video at this point. Work out number 3 in that order, expand it, replace and multiply and simplify, and see, and when you're ready, start the video again to see if your answer matches mine. Okay, at this point you should have squared x plus 5, which is x squared plus 10x plus 25. Replaced it, distributed your 2, brought that 3 down, and then simplified it by combining those like terms here, and then identifying your quadratic function values. A is equal to 2, b is equal to 20, and c is equal to 53. If you did not get this answer, go back and check your math and determine whether you had actually squared this and multiplied it out properly, and then check and make sure you distributed your 2 and then combined your like terms. At this point, please stop the video and do the same thing for this one over here. Once you have gotten your answer, continue the video to check your answer with the steps that I have when you return. Step 1, expanding the x minus 7 squared gives you this result, x squared minus 14x plus 49. Then you distribute the 3. Negative 3 times x squared, negative 3 times a negative 14, which is a positive 42, negative 3 times a positive 49, which is a negative 147. Bring my 2 down, and then combine my like terms by adding the negative 147 plus 2, which gives me a negative 145. And then identifying all my values in my standard equation, or my standard function. A equals a negative 3, b is equal to a positive 42, c is equal to a negative 145. And now moving on to some homework and practice. Again, you can always go to the student. Again, you can access the interactive student edition, which will give you all sorts of different kinds of videos. Remember, we're on Unit 8, graphing quadratic functions, interpreting vertex form, and this can take you through some of the lessons and some homework. If you click on Student Resources, again going to quadratic equations, graphing quadratic functions, interpreting vertex form, you've got a list of things that you can also practice if you want to do some additional practice or watch some videos. Going back to the homework and practice, I'm going to write a few problems down and then I will pause the video. You can pause it also while you work those out and then determine if you've got the correct answer and compare them to mine. Here are the first 4 problems. Please determine if the functions are quadratic. Again, we're looking for our standard form of ax squared plus bx plus c. So look at these and tell me if these are quadratic functions. Pause the video. Okay, here are the answers. There is no x squared listed in this, which means a equals 0. And because a equals 0, this cannot be a quadratic function. Number 2 is a yes. At this point, the a is equal to 5. When we change it to standard form, this 5 will move over there and it'll become a negative 5. But as of right now, we know we have an x squared value. Again, looking at number 3, we have an x squared value, which means we have an a value. This value is 2. And number 4, there is no x squared value present. That means that a equals 0. And because the x squared is absent, a equals 0. And therefore, this is not a quadratic function. Okay, now for our last 2 problems, our homework practice. Again, if you need to repeat this at any time, please rewind the video and watch it again. These, now, we have to convert we have to convert from vertex to standard form. Again, go ahead and pause the video. These will be worked out with the A, B, and C values identified. Check your math, double check it, and when you are ready, go ahead and replay the video and see if you came up with the correct answers. Okay, step number 1 is to expand x minus 2 times x minus 2, which gives you x squared minus 4x plus 4. Then you're distributing your 5, which gives you 5x squared minus 20x plus 20. Your 7's tagged on the end here. The last step is to combine your like terms and simplify, which gives you 5x squared minus 20x plus 27. Our A is 5, positive 5. Our B is a negative 20, and our C is 27. On number 6, expand. X minus 3 times x minus 3 gives you x squared minus 6x plus 9. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 6x, positive 24x. Negative 4 times a positive 9 is a negative 36. We tag in our negative 9, which is left over, combine our like terms for our final answer here. And A equals negative 4, B equals 24, and C equals 45, or negative 45. At this point, the part 1 of our lesson is over. Next time we will be finishing this by finding the axis of symmetry and converting from standard form back to vertex form. And we look forward to seeing you next week. Have a great week and good luck with your work.